Okay, in the last section we talked about the double angle formulas for sine and cosine and ultimately tangent as well. And if I have a double angle formula, that gives me a relationship between trig functions of two different angles, an angle and the angle that's twice as big. But if I have that relationship, if the bigger angle is twice as big as the smaller one, another way of saying that is that the smaller one is half as big as the larger one. So the half angle identities are really going to be capturing the same relationship. They're just going to be focusing instead of on the fact that the bigger angle is twice as big, they're going to be focusing on the fact that the smaller angle is half as big. Okay. So here's our game plan. I'm going to start with the sum formula for cosine. We're going to review how that leads to the double angle formulas for cosine. Now, cosine was the one that had three different versions. And the significance of that is that what falls out immediately from the sum formula for both sine and cosine gives me a relationship between three different trig functions. Sine of theta and cosine of theta, and then either sine or cosine of the angle 2 theta. Okay. But because the sines and the cosines of theta get squared in the double angle formula for cosine, we can use our Pythagorean identity to get it down to a relationship between just two of those trig functions. So we're going to use that, and then we're going to switch the focus of our relationship to focus on the fact that one angle is half as big as the other and get the half angle identities. Okay, so let's see how that works. The sum formula for cosine, remember, is that cosine of A plus B is cosine of A cosine of B minus sine A sine B. Okay, so we use that to get double angle identities because I can say that cosine of 2 theta is just cosine of theta plus theta. So I'm plugging theta in for both A and B. So I'm going to get cosine theta, and that's just cosine squared theta minus sine theta, and that's just sine squared theta. So cosine of 2 theta equaling cosine squared minus sine squared is what falls out immediately by just plugging into the sum formula. Like I said, that gives me a relationship between three different trig functions. Sine of theta, which is being squared here, cosine of theta, which is also being squared, and then cosine of 2 theta, which is not squared. Okay. But I know that I can use my Pythagorean identity. So if I want, I can replace cosine squared with 1 minus sine squared, and then I'm still subtracting the other sine squared, and that gives me that cosine of 2 theta is 1 minus 2 copies of sine squared theta. And that gives me a relationship between just two trig functions, sine of theta, which we're squaring, and cosine of 2 theta. The other option I have is I could use the Pythagorean identity to replace sine squared with 1 minus cosine squared. So I could say that cosine of 2 theta is cosine squared theta minus the quantity 1 minus cosine squared theta. And of course, we'll have to distribute that negative, and that's going to make this cosine squared positive. So then I get cosine of 2 theta is 2 cosine squared theta minus 1. And that gives me a relationship between cosine of theta, which is being squared, and cosine of 2 theta. So these two formulas are the ones that we're going to use to basically switch our emphasis from, hey, that angle's twice as big as that angle, to, hey, that angle is half as big as that angle. And that's going to give us the half angle identities. Okay, so I'm going to clear some space so that we've got some room to work this out. But what I'm going to do is I'm just going to make a substitution in my variables. I'm going to call 2 theta A. And if I do that, that would mean that theta would be A over 2. So when I call the angles theta and 2 theta, that sort of emphasizes the fact that the bigger one is twice as big. When I call them a and a over 2, that puts the emphasis on the fact that the smaller one is half as big. So what I'm going to do is I'm going to take this identity, that cosine of 2 theta is equal to 1 minus 2 sine squared theta, and I'm going to just write it with that different emphasis. So I'm going to replace 2 theta with a, so that's cosine a, and then I'm going to replace theta with a over 2. So that's 1 minus 2 sine squared of a over 2. All right, and now I'm going to just take that identity and I'm going to solve for sine of a over 2. Now right now this term is negative, so the first thing I'm going to do is add it over to this side, and then I'll subtract the cosine a over to the other side. So I'll get 2 sine squared a over 2 is going to equal 1 minus cosine of a. And then I can divide both sides by 2. So I get sine squared a over 2 is 1 minus cosine a over 2. Now, that's sine squared. If I want to get down to sine, I'm going to take the square root of both sides. Have to be very, very careful here, because it's very tempting to say that the square root of sine squared of a over 2 is just sine of a over 2, and it isn't. Okay? The square root function can never give me something negative, but the sine function is negative half of the time. So they can't be the same. In fact, anytime I have a variable expression and I square it and then take the square root, what that does is that gives me the absolute value. So the absolute value of sine of a over 2, which is never going to be negative, will equal the square root of 1 minus cosine of a all over 2. But if I wanted to solve for sine of a over 2, that means sine of a over 2 will be either plus or minus the square root of 1 minus cosine a over 2. Now that's the version that's given in your textbook, and I'm not crazy about that, because writing it that way doesn't really explain how do I know whether it's plus or minus. Do I flip a coin? Is it both? No, it is not both, because sine is a function, so it can only assign one value to any one input. Okay. So what I need to recognize is that when I'm working with trig functions, the sign, the plus or minus sign, is always determined by what quadrant we're in. And since we're looking at the sine of a over 2, this plus or minus sign is going to be determined by the quadrant that a over 2 is in. So be very careful. There are two angles in this formula. I don't care what quadrant A is in. I care what quadrant A over 2 is in. Okay, so we'll get some practice using this formula in the next video. But before we do that, I want to derive another formula. This is the half angle formula for sine of A over 2. Let's get the double angle formula the half angle formula for cosine as well. So here we started with one of the double angle formulas for cosine. I'm going to start now with the other one. Cosine of 2 theta is 2 cosine squared theta minus 1. Now, what I want you to do is basically mimic the work that we just did. You're going to take this identity, you're going to rewrite it in terms of A. So 2 theta becomes A, theta becomes A over 2. Once you've done that, solve for cosine of A over 2. Okay, so pause the video, try to do that, and then tune back in. Welcome back. Okay. So this becomes cosine of A. I replace 2 theta with A, and that's 2 cosine squared A over 2 minus 1. So theta becomes A over 2. So now I want to solve for cosine of A over 2. So the first thing I'm going to do is add over the 1. So cosine of A plus 1 is equal to 2 cosine squared A over 2. Then I can divide both sides by 2. So cosine squared A over 2 is cosine of A plus 1 all over 2. And now if I just wanted to get cosine, I'm going to take the square root of both sides. But I'm going to be very, very careful to remember that cosine is sometimes negative, but I know the square root is never negative. So this isn't cosine of A over 2. That's the absolute value of cosine of A over 2 is root cosine A plus 1 over 2. And what that means is that cosine of A over 2 will either be plus or minus the square root of cosine of A plus 1 over 2. And just like with the half angle identity for sine, this plus or minus sign is determined by the quadrant. And since we're calculating cosine of A over 2, it's determined by the quadrant that that angle, A over 2, is in. Okay. All right, so that's 2 new formulas that we have. Now, in the next video, we're going to get some practice using them. And most of the homework, and there's not much homework assigned for this section, most of the homework just has you do what we're doing in the next video, which is practice using these formulas. Do want you to be aware you're responsible for being able to derive them as well. So that's indicated in the posted homework. But this work that we just did, I could, on an exam, say, write the sum formula for cosine. Then write the double angle formula for cosine. Then use that to derive the half angle formula for either sine or cosine. So do make sure that you're studying this work. It's the same problem. I mean, there's one formula, so I can't really assign 10 homework questions on deriving the formula because you'd just be deriving the formula 10 times. But do practice this because that's, I think, one of the most important things is that you're able to derive one formula from another one rather than that you just have a bunch of them memorized. Okay.